Hello everyone, this is Indradeep Kumar, Assistant Professor IARE, Hyderabad. So now we will start the module 3. Okay, in this module we will see about the composite materials and the structure. Okay, so our introduction will be that. First topic will be composite materials. So first let's see what is introduction to the composites. Okay, so there is an unabated quest for new material which will satisfy the specific requirement for various applications like a structural, medical, household, industrial, construction, transportation, electrical and electronics. So materials of different types of materials are required. It's not like that some material like iron, copper is there. So with that all the things we can manufacture. Right. So for just creating that new one or required according to our requirement, just like a structural, medical, whatever the medical is, that material is required, definitely day by day we are improving that one. So that's why here is the unlimited quest for new material. Means all the time we are trying to get the new material so that whatever our requirement is that they in day by day life or anywhere that we can use. So that's why composite becomes a very popular nowadays. Okay, why? Because those things we will see in this one. So that's it. Metal are the most commonly used material in these applications. So here what is the metal generally we are using in the your or time in the your or time there have been specific requirements on the properties of these materials. So depending upon the time or it's in the upcoming time is there, that time there is specific requirement will be there. Like with this material only you can use this one. This material, if like iron is there, you can use at that particular place only. But what about the other place where we can use? So it's not necessary that for any component or like aircraft we can use everywhere aluminium or any iron. Means for different parts we require different types of material, right? So for that different types of material, what is required, how we will get that material, how to manufacture that material, what composition should be there, these things is required. So that we will see in this one. So it is impossible of any material to fulfill all these properties. So whatever the properties are required, it is impossible. Like iron is there, it's not like iron can sustain everywhere. Or just like iron having what property? It's getting rusted. Means if suppose with the iron we will make the aircraft structure, what happened? That after some time it will get rusted. Right? Next, iron is too heavy. So if you will use that iron for a whole aircraft body, then what happened? Weight of the aircraft body itself will be too much. Means now payload, that is like passenger cargoes and all, we cannot put into that one because already aircraft structure is too high. So any material, it's not like that if we will take the aluminium itself, only aluminium, then what happened? The strength will be very less because the aluminium is softer material. So only with the aluminium or alumina we cannot apply all the times. Wherever the things that more friction or more forces will be there we cannot apply aluminium. So it's not like that any one particular material we can apply anywhere, that everywhere of the aircraft structure or any type of structure. So depending upon the requirement, how much force they should carry or up to what level they should sustain, according to that we require the material. And for that only the concept came like what? The composite material. So in the following lecture, we will introduce the composite material, their evolutions, constituents, fabrication, application, properties, forms, advantages, disadvantages, etc. So in this module, we will see what about the composite material, that introduction, then their evolution, how they evolve or how they form from there, their history is there, right? And how they prepared or how they got. Then constituents, what are the materials in that is there by combining that they formed. Like just steel is there. In that steel, what happened? More than 95%, 99% iron is there. Then in remaining 1% zinc, magnesium, these things are there. So those are the constituent of that composite. Next, fabrication. How that will get fabricated. Different types of fabrication is there. So we will see the methods of fabrication, means how we can fabricate the composite. Next, about the applications where we can use that fabricated alloy, that means fabricated composites. So at different place we require different composites. So what composite you have or what we meant, so what is where we can apply that one or what is the application of that composite. Then properties of that composites, what are the forms of composites, then advantages of the composite and disadvantages of the composite. So these things we will see in this module. Okay, so first definition of a composite material. A composite material is defined as a material which is composed of two or more material at a microscopic scale and has chemical distinct phase. So see here, defined as the material which is composed of two or more. It's not necessary that only two is required, more than two also is possible, as just now told in this one, cast iron or steel, that iron, manganese, zinc, so more than two are there, so that is also possible more, but minimum two is required. If same thing is there of same type, like iron you are combining, that is not the composite. Definitely two different materials should be there, and that also at the microscopic scale. In the microscopic level, if we are combining, it's not like that take one iron sheet, okay, and put another aluminum sheet and then you can say it's a composite. No, right? That should be at the microscopic level and has chemically distinct phases. Once they combine, they will have the distinct phases. Chemically means you cannot see, okay, they are of the different type. Means in a steel, you cannot identify iron separately, zinc separately, manganese separately. No, you cannot find. All are combined, and because of that only improved property of iron we got in the form of steel. So these two things are very important for making the composite. So while making the composite, first we have to go with the microscopic scale, and then we have to check whether it's a chemically distinct or not. That means it should be in distinct phases. Then only we can say, okay, that whatever our composites are there, that is good. Thus, a composite material is heterogeneous at a microscopic scale but statically homogeneous at macroscopic scale. So just see, heterogeneous means different types of this one. It's not uniform, non-uniform. So in microscopic, if you will see, it's a non-uniform. But at the homogeneous, that means at macroscopic means at larger scale, what we can see. So there it's a homogeneous, just like a steel. You cannot find from the outer, if you will see from the outside, or that is steel, you cannot find inside where the zinc is there, where the manganese is there, or whatever the other elements are there and how they combine. But from outside you can see throughout of the steel having the same property, same luster, everything same. Means at the macroscopic level they are homogeneous, but at the microscopic level that are heterogeneous level. Why? Because it's not necessary all the zinc, like suppose zinc and iron combine continuously. Maybe zinc, iron, after that magnesium, like that is there. So that should be what? Heterogeneous. But from the outer side or at macroscopic level, that must be homogeneous. Okay. The material which forms the composite are also called as constituents or constituent material. Means through which what we are combining, just like zinc, manganese, iron, these are the constituent of the steel. So these are composites, means constituent of the steels are iron, manganese, zinc, or we can say iron, manganese, zinc. These are the constituent material of the steel. Okay. The constituent material of a composite have significantly different properties. So once we will combine that one, now that becomes the composite. So they will have the different property from the earlier one. Whatever those three have the distinct property, that separate property, once after combining at the microscopic level, they will have the totally different property. You cannot find individual of any property. Like whatever the property of zinc is there, if you will try to find zinc property in composition, that is in composite, you cannot find. Even though iron is too much, iron is more than 99%, then also you will not able to find the iron itself, that total or pure iron in that case, right? So whatever the property of iron is there, definitely that will get improved. Means iron is getting rusted. If that is combined properly, the other constituent, okay, then you can see steel is not getting rusted. Means now that iron property is not there. So totally different property they are achieving, and that's why we are using the composites. So that enhanced property we will get. However, a combination of two or more materials with significant properties will not suffice to be called as a composite material. So it's not like they're just combining two things and you can say that is the composite material. Just example, take sandwich, that bread, put jam, but you can say that is sandwich. No, right? whatever the things are there that should satisfy, means according to our requirement. In general, the following condition must be satisfied to be called a composite material. So these, right, so these property must be there, then only we can say that is the composite material. Okay, so now first property is, right, so these three, if they will satisfy, then only can say okay, now we form the composites. So that's why you can see we are saying not steel as composite. I'm giving just example steel because of the constituent. But if you will say that steel is composite, no, steel is not composite. Steel is alloy, mixture of two or more than same thing. But the condition for the same thing, instead of just now I tell 99% steel is there, sorry, iron is there, remaining 1% the other things are there, that time so same thing becomes alloy. If 90% is iron, right, and 10% is zinc or other things, then we can say that forms a composite. Okay, so this way the combination of materials should result in significant property changes. So means whatever the property changes that is significant, that we can see okay, their property got improved or changed. One can see significant changes when one of the constituent material is in platelets or fibrous form. So that should be either in platelets forms or in fibrous form after seeing the significant changes. So that is the first condition. Second condition is what? The content of the constituents is generally more than 10% by volume. So whatever the constituent will be there, that should be more than 10%. Like suppose now same this steel alloy. So instead of 90% iron, now just take 80% iron, 10% manganese and 10% zinc. Right. So now this will form the composite. Same thing as here, just after increasing the percentage, if less percentage, that is called alloy. If more than 10% of those constituents are there, that is called what? The composite. Okay, so here only you have to keep in mind that constituents volume, that means constituent amount, should be greater than 10% whatever the quantity is there. If 200 gram is there, right, total composite weight is 200 gram, in that more than 20 grams should be that a specific constituent. Whatever you are adding, you can add here what 200 means you can add 20 constituent of 10% everyone, sorry 5% all, right, if to whatever. So same way you can add, means 10 constituent we can add 10% all, 20 constituent 20%, 5% all, 50 constituent if you want to add, you can add just 2% all, that also is fine, you can add those, but there you cannot. 10% is required, 50 you cannot, 20 no, because why? All 5% are there. So up to 10 you can go for 10% all, or like that means that should be all the constituent must be greater than 10, right? So depending upon how many constituent you can add, according to that you can form the composite. So this is the second condition. So that's why in 50-20 we cannot form a composite because their constituent proportion will be less than 10%. In general, property of one constituent is much greater than the corresponding property of the other constituent. So whatever the property of one constituent is there, the other things we are adding, that must be greater, then only we can add. Okay, the composite material can be natural or artificially made material. In the following section we will see the example of these materials. Means generally it's are of two types. First one is natural, that is occurring in the nature, and second one is artificially made, that is prepared by us. Okay, so now we will see that one. So first see why we need these materials, right? So these are the property. Okay, so just here there is unabated thirst of new material, that means thus require, thirst means well, just a requirement of that new material with improved desired property depending upon our requirement. All the desired properties are difficult to find in a single material, means generally what we required in that materials, these are the property. So for any particular material this is very difficult to achieve all the 16 this one, right, properties. Okay, so means we cannot go with that same one. So for example, a material which needs high fatigue life may not be cost effective. If you will get the high effect in that fatigue life, that may be costlier, but what we require, that lesser in cost. For that only this is required. The list of the desired property depending upon the requirement of the application is given below. So these are the desired property. What? First one is strength. That must have strength. That means greater strength, then only it can sustain the load. Then stiffness should be there. Means it should not, after applying the load, it should get break. There stiffness should be there. Then it's a tough also is required. So toughness should be there. The next is high corrosion resistance, means it should not get corrode, and that's why in iron we are adding zinc, but there we are forming alloy. But what we required here, composite, so that also should not get corrode. Then high wear resistance. So after even that performing the operation, it should not get, that means wear and tear should not be there. Then high chemical resistance, means it should not react quickly. Okay, so whatever the composite is, suppose you made a composite and you just put into the air or just put into the this one inside, like you can see the very big size containers they are forming, and they are keeping the petrols, right? Petrol, diesels. So if suppose in that composite they will keep the petrols and that starts reacting with the petrol or diesel, then what happen? After reacting, they will form their oxide, and that might be cause fire or anything. So that must be chemically resistance, or you can say the chemically inactive. But chemically inactive is almost impossible, that 100%. So that's why as much as maximum we can provide the resistance, that is good for us. Next, high environmental degradation resistance. So high environmental degradation means it should get degrade not that much easily. Okay, otherwise what happen, if it will degrade, you will just keep one composite. After 2 days you will see, okay, that is disappear. So that should not be there. Then next is the weight should get reduced. Then why? Because if it's higher, then we cannot use. Then high fatigue life. The fatigue life also should be high. Thermal insulation or conductivity should be greater. Electrical insulation or conductivity should be again greater. Means electrical insulation should be there. It's not like that even after touching the wire you will get soft. Then acoustic insulation means when we use the acoustic, that's the high frequency wave, that sound, right? That should not get affected, right? Then radar transparency, energy dissipation, reduced cost and attractiveness. That also is very important, that attractiveness. If you don't feel that attractive is there, then no one will buy. Suppose dress is there, right, and that is not attractive, then whatever, we will not buy. So even that composite also the same thing is there, that should be attractive. Okay, so these properties are required for our daily life. Many properties are there, but these are the most important 16 property what we are considering for anything. But all the 16 property are very difficult to have only one composite. So that's why depending upon where we require, suppose we required somewhere a strength and a stiffness, then according to that we will make the composite. Sometime somewhere in the same place we require high corrosion resistance and high wear resistance. Suppose high corrosion resistance, where corrosion will be there outside of the aircraft, where it comes in the contact of oxygen and water. So those outer surface or outer skin should be what? Corrosion resistance. High wear and tear. Wear and tear will be what? Like luggage compartment will be there, then upper surface will be there, footboard will be there, because many passengers are climbing on that one, right? So there also it's not like that, okay, that this one is stair is there, and after that once you will put the one or two people, that will get damaged. So that also wear resistance should be more. So that's why depending upon what property we achieved in that composite, according to that we will use at that particular places. Now come to composites. So what are the constituents in a typical composite? So that's it. In a composite, typically there are two constituents. One of the constituent act as a reinforcement. Reinforcement was which supports, and the other acts as a matrix. So first one is reinforcement material, and the second one is matrix. Sometimes the constituents are also referred as phases. So in which phase? That is there, right? So generally it's of two types. That one is reinforcement, so the second one is matrix. So best example is what? Just roof, that floor house roof. You can see when they are making that one, that time what they are doing, they are just putting this one like iron mace type. Okay, first they will put the wooden block inside just to support. They will put the pillar and all so that they can support this wooden block. Over the wooden block, what they are putting? This iron type mace. Okay, and in that they are putting the mixture of sand, brick, that the stone and cement and all, their mixture. And after once it's get dried, then what they are doing, they are just removing that wooden blocks, that wooden seats just to support. So now this iron net is called here reinforcement. If they won't provide the iron, this net miss, then what happened? That concrete, that structure won't be that much stable. That means they won't have that much strength. So their iron mace works as or act as a reinforcement, and the other material just like combination of sand, the stone, and what you can say this one cement, combination of that will be here or as a matrix. So that is matrix, and iron rod is the what reinforcement. Next, what are the type of reinforcement? So first, the reinforcement is a composite material come in various form. These are depicted through figure 1. So this is the type of composite. So first, continuous fiber. So this is the reinforcement, and remaining thing is what? That is the matrix. So in this case, this is reinforcement and remaining is matrix. So this is that short fiber or viscose. That may be either short fiber or viscose. And another type, just like particulate. So just see here, it's not necessarily also at macroscopic level, it's not necessary that should be homogeneous. So here you can see the bigger size, the smaller size, that is heterogeneous type. Here again in this case you can see they are at the different arrangement is there, different shape is there. So at the microscopic level, that is not necessary that should be homogeneous. That is heterogeneous, but at macroscopic level that should be homogeneous. So whatever you are seeing here, that must be seen throughout. Okay. Next, now type of reinforcement. So fiber, first one is fiber. Fiber is an individual filament of the material. So that is just like individual one fiber filament is there, that one fiber. And best example is our here. Here is also a fiber, but that is not of the material. So here that should be made up of material. Just now I give an example. This one is a fiber, that iron rod is fiber. Okay, a filament with length to diameter ratio above 1000 is called fiber. So length to diameter means what? That should have very long length, but diameter should be very small. If that is there, then we can say that as fiber. So length to diameter ratio should be greater than 1000, then that is fiber. The fibrous form of the reinforcement is widely used. So now in fibrous form only mostly we are using. The fibers can be in the following two forms. So now types of fibers. So first, continuous fiber, and then short chopped fiber. That is different short one. So if the fiber used in a composite are very long and unbroken or cut, then it forms a constituent continuous fiber composite. So just see here, this is long, it won't cut anywhere, so that we can see that is the long fiber. But in this case you can see this is also in the terms of fiber, because whatever the length is there and their diameter should be greater than 1000, that is there, but not in the longer size. So means this is the type of short fiber. So that's why it should be unbroken and the length should be very large, then we can say that is a continuous fiber. Short or chopped fiber, the fiber are chopped into small pieces when used in fabrication of composite. A composite with short fiber as reinforced is called as short fiber composite. So where we are using the short fiber, right, just small fibers in that one, that composite is called as what? Short fiber composite. In the fiber reinforcement composite, the fiber is the major load carrying constituent, right? So fiber is the major load carrying constituent. So whatever the fiber you are using, or you can say the reinforcement, that is the most major load, that is most load carrying constituent. So that's why we are using iron mace instead of that. We can use any small iron or very thin iron piece also. No, we are using very thick iron rod, there are iron bar, you can see. Why? Because that only is the holding total weight of the floor. Or just like suppose 4-story building is there. So at the ground floor, if you will use a thinner diameter iron rod, and above that one, suppose you are making 5-story building. So on that rod, the above all the 4-story, that this one part will be the total weight will act on that iron rod. Means this should be very strong compared to the all. Then above to that floor, that should be slightly lesser stronger, but even though, because above that 3/4 are there. So at that ground, that's why you can see they are people are well making their home. They are making their base to very strong. Why? Because the base only will hold all the whatever the number of floors are there, right? That much load. Okay, so that's why the base should be very small, sorry, very strong for a building. Anyways, means wherever the base is there, you can see, even in aircraft also you can see like this one is there, right? So here this size is very big, right? Like this is there. So this size is very big. Why? Because this only holds the total load, combining this one, then other things and load acting on that thing. So at this joint, it will be more. Now second one is short. So okay, this one. In the fiber reinforced component, the fiber is the conveyor load that we see. Now second one is what? Particulates. The reinforcement is in the form of particles which are of the order of a few microns in diameter. That type of particle is used as a reinforcement, just like what? Iron rod. Then we can say that is the particulates. So just now I told you in matrix also, without a rod, if you will add what? Cement, sand, and this one, that stone, small stone what we are dying. So that time that is the particle. So that will be just like a particulate. So there again the same force will be handled by those small stone only. The particles are generally added to increase the modulus and decrease the ductility of the material, sorry, of the matrix material. So what is why particulates are adding? To increase the modulus and decrease the ductility of the matrix material. Okay, or the best example you can see like dairy silk is there. Dairy milk silk, that chocolate. In that what happened? They are just adding nut and all. So then after adding nut, what happened? Their taste get improved. Right. So that is what? That is the particulates. Okay, and the whole thing is your composite what you required. Okay. Matrix. Okay. The particles are generally added to increase the modulus and decrease the ductility of the matrix materials. The particles are generally added such that one will increase the modulus and the other one will decrease the ductility. Means what you have to do? You need to increase the modulus and decrease the ductility. Means it should be that much stronger, because if ductility will be there, then easily it will break. So try to reduce the ductility and try to improve the modulus of elasticity. In this case, the load is shared by both particles and matrix material. However, the load shared by the particles is much greater than that of the matrix, right? However, the load shared by the particles is much larger than the matrix material. So whatever load is shared by the particles, that is much larger than the matrix material. For example, in an automobile application, carbon black as a particulate reinforcement is added in rubber as matrix material. The composite with reinforcement in particles from form is called a particulates composite. So just what? Reinforced should be particle, then that type of this thing is called as the particulate composite. Next is again same type of reinforcement. So third one is flip. We had already seen three image, right? Continuous, fibrous, and this is the particulate one. So now we will see the third one. Flake is a small flat thin piece or layer or a chip that is broken from a larger piece. Since these are two-dimensional in geometry, they impart almost equal strength in all direction of their planes. So they are almost of the same, so their load will be shared by both. Thus, these are very effective reinforcement components. The flakes can be packed more densely when they are laid parallel. Okay, the flakes are parallel, then it will be more denser, even denser than unidirectional fiber and sphere. So in case of that direction, it will be same. In case of reinforcement of that reinforcement is used. So for example, aluminium flakes are used in paint. So that's why you can see, you can add that one. Aluminium paint is there. So that's why salo sal just in Hindi one add is there, means it goes for a very long time. So flakes are used in paints to make aluminium plate. They align themselves parallel to the surface of the coating, which imparts the good property. So after adding what they are doing, they are aligning themselves parallel to the surface of the coating, which imparts the good property. Okay. Now fourth one is whisker. These are newly perfect single crystal type fibers. These are short, discontinuous, and polygonal in cross sections. These are what? Whiskers are of single crystal fiber. These are short, discontinuous, and it should be what? That discontinuous and polygonal in cross section. So that cross section should be polygonal, that are of any type, either circular, rectangular, square, whatever that may be of any type. Now classification of composites. So already we had seen these four are the type of that composite. Actually this should be here. Okay, now just take this as first fiber. So fiber are of two type: composite fiber, discontinuous fiber. Then now this continuous fiber, again that will get divided into what? This one, unidirectional and woman. Okay, then let's see here, woman three dimensional. Then after this, this one form the single layer or a multi-layer based on their single layer and multi-layer. Also their different name is there. So that also is important. After this, once you will reach here, then okay, so this you can directly say that is the multiplayer. So single player, this will be the multiplayer. You can play or you can just use with laminates and hybrids. So this is for multi-user and this is for what? A normal one. So this is the classification of fiber composite materials. Now, why are reinforcement made in thin fiber form? Okay, so there are various reasons because of which the reinforcement is made in thin fiber form. These reasons are given below. So first reason is what? An important experimental study by Leonardo da Vinci on the same tensile strength of iron wire of various length is well known to us. Why? So that's this Vinci, the tensile strength of iron wire is various length is known that only day. Wire of the same diameter with shorter length should have higher tensile strength. Right? Means same diameter, same length will be there, then also some different, because of the different material they will have the different strength. The reason for this is the fact that the number of flaws in a shorter length of wire is small as compared to long length. So whatever the flaws are there, that is what less than that Further, it is well known that the strength of a bulk material is very less than the strength of the same material is wire form, as the fiber can made of thin diameter. The inherent flaw in the material decreases, hence the strength of the stress of the fiber increases as the fiber diameter decreases. Why are reinforcement made in thin fiber form? That continue. Yeah. So next is B. The quality of land transfer between fiber and matrix depends on the surface and between fiber and matrix. Right? So the quality depends on what? Depends upon. Okay. So it can be shown that for given volume of fiber in a composite composite, the structure are the surface are between fiber and matrix increases. If the fiber diameter decreases, let D be the average diameter of the fiber, L be the length of the fiber, and M equals to. Then the surface area available for load transfer is what? Pi dl. So just see how pi dl will be there. What is the surface area? Surface area of cylinder is what? Right? Pi d by 2 pi d and L. This is equals to what? Sigma. Because pi, then capital N, then small x, that is real. Okay. So this will be the value of what? A, that is the surface area available for load transfer. Later we will check this value and we will submit according to that. So first just see the volume of these fiber in a composite is, the volume of these fibers in a composite is, already I mentioned you that it should be less than what? 400 gram. So whatever there is there, you can just give, but it won't fly that one, or it won't get sustained. The volume of these fibers in a composite is, so this is for what? Non-composite or just laminar one. Now second is coming for fabric, this one, that volume of these fibers in a composite, that one. So their volume is what? Same. You can just put volume height into length. So put here height into length, so that we can write like here. So see, multiply with this a pi d square. So volume is V. So according to this, what happened? This one, pi r square, okay, by L, or pi b square by 4 into L. Okay, so that will be the formula for volume. Next, why are reinforcement? So that only we are continuing now. Now let us replace the fiber with a regular average diameter D. That means instead of that, later we can remove that 2 and replace to the D given. So just assume that as D, of such that the volume of the fiber is unchanged. So that's why it should not get changed. So here N is okay. Then how many numbers of fiber is required? So how you will find that a small n equals to capital N, that is that what? Capital N is what? Let's see here. Total number of turn. Right? Now let us replace the fibers with a smaller average diameter D of such that the volume of the fiber is unchanged. So if it's fit, this volume is, that means diameter is not, or volume is not getting changed. So for then the number of fibers required to maintain this same fiber volume is what? Given equals to N equals to pi. So N equals to N into D by A square. So that is proportional. So after proportionality constant, that N by will be there. So this becomes A double dash. Actually this should be A star will equals to N pi D square by 4 into L into जो 4 एग्जाम का आएगा वो A N pi D square by L equals to what? 4 into just see 4 into volume of the fiber into 1 by B. So just see the properly 4 into volume of the fiber. If you will simplify this one, our volume of the fiber will be what? Pi r square. That's N pi r square. In previous question also we had seen. Okay. So thus for a given volume of fiber in a composite, the area between fiber and matrix is inversely proportional to the average diameter of the fiber. So whatever is there, that is just nearly inversely proportional to the average fiber size. Okay. Next, C part. The fibers should be flexible so that they can be bent easily without breaking this property of the fibers. It is very important for woven composite. This property of the fixed fiber is very important for woven composites. In woven composite, the flexibility of fiber plays an important role. Ultra thin microcomposite are used for development. Okay, so ultra thin composite are used in what? Deployable structure. The flexibility is simply the inverse of the bending stress. The flexibility is what? It's a reciprocal of bending stress. Or as you can see, it's inversely proportional to the bending stress. From mechanics of solid, that we studied earlier, that the bending stiffness is EI. So EI should be what? It's a proportional to 1 by d power 4, that one. Where E is the Young's modulus of the material and is the second moment of inertia. So Y is what? Second moment of inertia. That Y of that moment of moment, that only is called the second moment of inertia, and in simply we are saying that is inertia. Right? So for a cylindrical fiber, the second moment of inertia I is pi d4 by 64. So this is the moment of inertia of a cylindrical fiber. Thus, from these two, flexibility is directly proportional to 1 by E d power 4. Now, the functions. What are the functions of a reinforcing agent? The function of a reinforcing agent are: these are the main load carrying constituent. The reinforcing material in general have significantly higher desired property. Hence, they contribute the desired property to the composite. It transfers the strength and is shifted to the metric material. So what they are doing is transferring the strength, that means from iron rod to cement, that transferring, that means stiffness, that or matrix material will be there or strength will be there. Now, what are the functions of a matrix material? The matrix performed various functions. These functions are listed below. So first function is what? The matrix material holds the fiber together. Okay, this matrix material we can use and their fiber will be holding properly. Right? At the microscopic level it will be non-uniform, and at the macroscopic level it will be uniform. Then second is the matrix plays an important role to keep the fibers at a desired position. Right? The desired distribution of the fiber is very important from micro mechanical point of view. Right? The matrix next is the matrix keeps the fiber separate from each other so that the mechanical aberration between them does not occur. So because of that, it's not one or two simultaneously, it should be there. Right? So that's why whatever the property is there, that should be different. If it transfers the load uniformly between fiber further. So if further is there, then also you have to apply the same weight. Okay. So if it transfers the load uniformly between fibers, further in case a fiber is broken or fiber is discontinuous, then it helps to redistribute the load in the vicinity of the break site. Next is it provides problem on fibers from environmental effect. Okay. Next is it provides better finish to the final products. Whatever the final product is there, if you will use this composite, that will give you the better result. It provides better finish to the final product. So with this better finishing also we can achieve on the product. Next, the matrix material enhances some of the properties of the resulting material and a structural component that fiber alone is not able to impart. So now that fiber and iron rod that can sustain the roof, even that mini building. But suppose if you will put only the iron mace over there, then what happen? After some time it will fall. Okay, so that also should be very strong. For example, such properties are transverse strength of alumina and impact resistance. Now, what are the types of fibers? The fibers are used in the fabrication of a composite can be divided into two broad categories as follows. So first one is what? Natural fiber. Second one, advanced fiber, or you can say that synthetic fiber also. So first, natural fiber. The natural fiber are divided into following three subcategories. First one, animal fiber like silk, wool, spider silk, sinew, camel hair. So these are we are getting from animals. That's why animal fiber. Plant vegetable fiber. So what we are getting from the plant, that is given as the plant fiber. Or vegetable, if you are getting from the vegetable, then it's vegetable fibers. Cotton, seed, jute, a stem. So from the cotton, we are getting from the seed only, we are getting the cotton fiber. From jute, from the stem, we are getting hemp, again a stem, sisal, leaf, rami, bamboo, maize, sugarcane, banana, kapok, wire, abaca, canaf, flax, raffia, palms. So these are the plants, vegetable plants or vegetable fiber. Minerals fiber, asbestos, basalt, mineral, wool, glass, wool. So these are mineral fiber that is occurring in nature. Next is advanced filter, that or you can say that is this one, synthetic fibers. An advanced fiber is defined as a fiber which has a high specific stiffness, that is ratio of Young's modulus to the density of the material, that is E by rho value should be what? Very high. Then only we can say that advanced fiber is there. And a high specific strength, that is no ratio of ultimate strength to the density of the material, that is sigma alt by rho. Okay. Next, what are the advanced fiber? The fiber made from following materials are advanced fiber. First, carbon and or graphite, either carbon or graphite. Then glass fiber, alumina, aramid, silicon carbide, sapphires. So these are the types of fiber. Okay, so let's see. Once again, I am repeating quickly. Right, what we are seeing first. Let's see here. In this composite material and structure, then what we are seeing, that introduction to composite. What is composite? How it behaves? Why it's required? The next definition about the composite materials. Then we are seeing what these three very important things, that important points or important conditions is required for the composite. These three conditions met, then only we can say okay, whatever the required composite is there, that we achieved. Next, why we need? Because of these properties, we cannot get in all the properties in same material. So just to get as maximum as property in that composite is possible by preparing that composite, so maximum property from here and enhance from the existing one. Then composite type of composites, what we are seeing, that continuous fiber, short fiber, or viscose, or particular. So these are the types. Then fiber, then what is fiber? Continuous fiber, short fiber. So if continuous means what? If it's very long length, then if of very long length, then it can say continuous. And the fiber should be, that means length to diameter ratio should be more than 1000, then only we can say it's the what? Fiber. Right? Then next is short or choked fiber. So either it's a smaller size, or if it chokes, then we can say that is short and choked fiber. Then now try this one. Second one is what? Particulates. Particulates means just a small, or you can say just a sprinkle in the chocolate, that just behave like particulates. That here particulates, this one, that means experiences the more load compared to the matrix. Similarly in fiber case also. Then next is flake, that is small, similar to the carbon fiber, or just like a chip type we are adding in that one. So that is the flake. Then whiskers are what? It's nearly perfect single crystal fibers. Only single crystal should be there. These are short, discontinuous, and polygonal in cross section. So these are, that may be of any cross section, either it's triangular, rectangular, hexagonal, heptagonal. So these are their cross section is there. Then next, what we did, that classification. So these are the classification. Then by reinforcement made in thin fiber form only. So if it's a thicker form will be there, then what happened? Already it's too much weight will be there. Even we cannot carry, and that all the load will be on that one. So instead of that thicker, just divide into the thin part and then use as a mesh, just like in the roof, that iron mesh I explained. Okay, so what will be the surface area? That pi dl will be the surface area. Total surface area will be what? Pi d and L. So n pi dl and will be the total number of load. Okay, so how much area is available for load transfer? This much. How much volume is there? That will be what? N pi d square by 4 into L. So here, just here, this pi d L, that is the area, right? Why? Because we had seen the form, this one, surface area of this is what? Pi r square. So 2 pi r and into this one. But in case of volume, that is volume of the cylinder is pi r square h. So here pi r square h is the r is what here? D by 2. So pi d by 2 whole square into h is L here. So this will give you pi d square L by 4, and that is here. Okay, so this is this one. Now what is the 2 pi r is the surface area and L. So 2 pi r. Now here r is what? D by 2. So 2 pi into d by 2 into L. 2 cancel. So pi dl will be the surface area, and if for n number, n into pi dl. So this will be the total area available for load transfer. This is the total volume. Okay. Now same thing for how many numbers of fibers are required. Then we can find by this method. Then the new surface area between fiber and matrix, how much area will be there? By this formula we can find out. You can say 4 into volume of the fiber, whatever is there, into 1 by d, or simply 4 volume of the fiber divided by t will give you the total fiber in between, that how much area is there. So these 4 formulas are important. Then about the flexibility is what? This is inversely proportional to the strength, that is stiffness of that EI, and that is d power 4 E d power 4. Why? Because I is pi d power 4 for the cylindrical fiber. Okay, then functions of reinforcement, what? It's the main load carrying constituent, then reinforcing material, transfer the strength and stiffness. So these are the functions of reinforced material. Functions of a matrix, how matrix is there. So these are the functions of matrix. Then types of fiber, that is natural fiber, advanced fiber. 2 types are there. Natural fiber means what we are getting from the nature, matter of animal fiber, plant, vegetable fiber, minerals fiber. And second is what? Advanced fiber, in which we use the advanced material, that is called advanced fiber. Okay, so this is the reference from where that NPTEL, this is the course code that already is there in the NPTEL. So you can see there also, there again video is there, course content that is there. So you can just refer that one, or if suppose in this still you have any doubt, you can just comment on the video. I will clear your doubt, or you can just ask me regarding your doubts. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.